Alright guys, so far for your Form 4 Chapter 5, for the Form 4 Chapter 5, the chemical bonding, we have covered two major bonds. So the first bond is actually ionic bond, and then the second one would be covalent bond. Yeah. So these are the two major bonds that we have learned. Okay. So today our focus is to learn something on KSSM new bonds. Okay, so there are total 3 KSSM new bonds that you need to know. Yeah, so these 3 bonds we don't need to learn back in KBSM, but for your new syllabus KSSM you need to know about them. So the first one, it's called hydrogen bond. The second one, it's called dative bond. And then the last one, it's called metallic bond. Yeah, so these are the 3 new bonds that is being introduced to your KSSM new syllabus. Okay, you don't need to know too deep about them. Yeah, these 3 new bonds, you don't need to know too deep about the entire idea. Okay, you just need to know some rough concepts will do. I will advise for these 3 new bonds, try not to refer or read any textbook or reference book. I mean, you can do that if you want to get extra information, but it is very confusing. Okay, because previously they only learn hydrogen bond, dative bond, and metallic bond when they go for Form 6. When you go for Form 6 or when you go for A levels. Okay, but now you are learning this in your Form 4. So you are not going as deep as you should know in your Form 6 and A level, which is your pre-university lah, pre-U. So for these 3 new bonds, you just need to know the basic will do. Just know the basic will do. Yeah. Okay. So I will further elaborate one by one. Okay. So let me start with the first one. So the first one, it's called hydrogen bond. Okay. So you must first understand, okay, who can form hydrogen bond, because I need you to understand that not everyone can do hydrogen bond. I repeat, not everyone can do hydrogen bond. So if you want to form hydrogen bond, you must fulfill this requirement. These are the requirement, okay, in order to form hydrogen bond. Okay, so first requirement, as you can see already, hydrogen bond come from the word hydrogen. So if you want to form hydrogen bond, that fella, that substance, or we call that molecule, must actually contain hydrogen. Yeah, it must contain hydrogen. If you don't have hydrogen, how on earth you can form hydrogen bond? Okay, so this is the first one. Make it as a checklist. Okay, the second requirement is that, okay, if that fella got hydrogen, it doesn't guarantee that it can form hydrogen bond. So you must make sure that the molecule got hydrogen, and you must make sure that the hydrogen on the molecule is actually attached, okay, to these 3 fella. Okay, it must attach to 3 fella. Okay, this first fella called F, which is called fluorine. O is called oxygen, and then N is nitrogen. FON. I teach you how to memorize later. F is actually your fluorine. Okay, F is the fluorine. O is the oxygen, and then N would be the nitrogen. Yeah. Okay, alright, so this is the second checklist. Okay, so you must have H, and then the H must bonded to FON. Okay, I teach you how to memorize this, then we will run through some example. So this is a simple tips for you to memorize it. Okay, so these tips, we call it high. Okay, we call it as, okay, high phone. Yeah, high phone. Alright, so simple thing. Okay, you know about iPhone. So in front of the iPhone here, you add the H, it become high phone. Yeah. Okay. All right. So what it means by high phone? The high-phone, actually the high is referred to hydrogen. Okay, the high is referred to hydrogen. The phone, actually we are talking about F-O-N. Same pronunciation, phone, F-O-N. F is fluorine, O is oxygen, N is nitrogen. So I repeat again. So the way we remember it's iPhone, okay, with the extra H become high phone. High phone, the H stand for hydrogen. The phone, same pronunciation as F-O-N. So in order to have hydrogen bonding, we must have a molecule. That molecule must have H, and the H must sticking or come along with phone, F-O-N. Okay, I give you some example here. Okay, let me give you some example. Okay, so let's say we have water. Okay, water, the formula is H2O. Okay, so if you draw it out, you don't need to know how to draw. Okay, you don't need to know how to draw this. I just do a demonstration. So H2O, you have O bonded to 2H. So is water capable to do hydrogen bonding? So the first requirement is that, do you have hydrogen? Do you have hydrogen? Yes, we have hydrogen. So that's the first requirement. Number two, do you have phone? Yes, the hydrogen attached with F-O-N, we have a O. So since you have H, you have phone, so water is capable to do hydrogen bonding. Water is capable to do hydrogen bonding. Okay, so this is what we need to know. All right, so one more. Okay, we have another substance called hydrogen fluoride. All these examples, please don't memorize. I just want you to get the concept. I don't want you to memorize every single thing. Okay, the second thing is called hydrogen fluoride. Okay, so for hydrogen fluoride, okay, the formula is HF. Okay, so this is the drawing. We don't need to know how to draw. It's a H attached to F. So hydrogen fluoride got hydrogen. Then the hydrogen attached with FON, the F. So since you fulfill both requirements, high phone, so hydrogen fluoride is capable to do hydrogen bonding. Yeah, hydrogen fluoride is capable to do hydrogen bonding. Okay, so next one, okay, we have an ammonia. Okay, let's say now we have another substance called ammonia. So for ammonia, the formula is NH3. Okay, so if I draw it up, it's N attached to 3H. Okay, now same thing. For ammonia, we have hydrogen. All right, so that's the first requirement. And the hydrogen attached to FON, FON, the N. So we have H, we have FON, so ammonia can do hydrogen bonding. Okay, so that's it. So water, hydrogen fluoride, and ammonia all can do hydrogen bonding because they fulfill the rule high phone. They have H, they have phone. Okay, so that is the requirement for us to do hydrogen bonding. Yeah. Okay, now let's do a very quick self-test here. Okay, let's do a quick self-test before we move on to the second part. Okay, so we'll do a self-test like this. Okay, so we need to identify. Okay, we need to identify the substance below. Okay, so I'll give you a few substance. The substance below able to form hydrogen bond or not. Yeah, so I'll give you a few substance. We will learn together whether they can or cannot form hydrogen bond. So let me make a simple table here. So this is a substance, and then this is a capability to form hydrogen bond. Okay, so the first substance is NaCl. Okay, so for NaCl, do you think this fella can do hydrogen bond? To do hydrogen bond, remember what's the requirement? Okay, high phone. So can the NaCl form hydrogen bond? Nope, because you not even have hydrogen. Okay, NaCl got no hydrogen at all, so cannot. So second one, we have HCl, hydrochloric acid, or we call hydrogen chloride. So for hydrogen chloride, can you form hydrogen bond? So do you have hydrogen? Yes, we have hydrogen. But do you have phone? No, you don't have F, you don't have O, you don't have N, you have Cl. So cannot. So this is a very important concept. You don't think any substance that got hydrogen, then they can form hydrogen bond already. Nope. You must have hydrogen, and the hydrogen must sticking or come along with phone. So the third one is hydrogen sulfide. So hydrogen sulfide also got hydrogen, which is the first requirement, but it doesn't have the phone, so cannot lah. Okay. Alright, so let's move on a little bit more. So next one we have ammonia. Ammonia got hydrogen, and the hydrogen is sticking along with N, FON. So yes, ammonia capable to do hydrogen bond. Next one, carbon dioxide. So can carbon dioxide form hydrogen bond? The answer is no, because carbon dioxide not even have hydrogen. You not even have hydrogen. No way. The next one is water. Okay, the next one is water. So for water, do you have hydrogen? Yes. Is the hydrogen attached to phone? Yeah, you have O here, FON. Yes, you can form hydrogen bond. Last one is CH3OH. Okay, you don't need to know by now. You will learn more in your Form 5. This is an alcohol we call methanol. This is methanol. Don't need to memorize. They won't ask in your Form 4. Okay, so for methanol, can you form hydrogen bond? Yes, there is hydrogen. Okay, and then the hydrogen attached to O, FON. Yes, so methanol also capable to do hydrogen bond. Okay, so that is the first part. So I hope by now you should able to understand who can form hydrogen bond, who cannot. Okay, now the second part that we need to learn together is this. Okay, how the hydrogen bond is formed. Because for the first part, we only learn who can form hydrogen bond. So now we will learn how the hydrogen bond can be formed. Yeah. So hydrogen bond can be formed by this. Okay. Hydrogen bond is the attraction. Okay. Hydrogen bond is the attraction, or we call force of attraction, between hydrogen atom. Okay. So this hydrogen atom on a molecule. So the hydrogen atom on one of the molecule is actually attached, with FON, fluorine, oxygen, or nitrogen atom on another molecule. Alright, so in short, H of one fella bonded to FON of another fella. Okay, H of one fella is actually stick to FON of another fella. So that is hydrogen bonding. Okay, give you a few examples here, maybe 2 or 3 examples. Okay, the first example, let's say we have water. So water can form hydrogen bonding because water, you can see, got H2O. So water got H and you got FON. So water capable to do hydrogen bond. Okay, so now I draw 2 water here. I want to show you how these 2 water, they are capable to do hydrogen bonding. Okay, so you see, the H of one of the molecule will go to attach with the FON of another molecule. So it's not the same molecule. It's not the H of the same molecule attached with the O of same molecule. No, it must be different. Okay, H of this is one whole molecule. This is one whole molecule. Yeah, so the H of this molecule will attach with the O of another molecule. So this force of attraction in between them, this is called hydrogen bond. Yeah, so this one we have hydrogen bond. Okay, all right, so I'll show you another one more example. So let's say the second example we have can be a, let's say, hydrogen fluoride. Okay, let's say we have hydrogen fluoride. So hydrogen fluoride, the formula is HF. So same thing, let's double check. HF can form hydrogen bond because HF has H, HF has FON. When you have a molecule, the molecule got H, the molecule got FON, so you can form hydrogen bond already. So another HF here. Okay, so now I want to show you how this HF form hydrogen bonding with this HF. Okay, so remember, for hydrogen bonding, the H of one fella, okay, will go to form the bond with FON of another fella. So the H of this fella will form the bond with F of another fella. So this is your hydrogen bond. Okay, so this would be your hydrogen bond. Okay, so like what I said just now, you don't need to know too deep about hydrogen bond. In SPM for your Form 4, you just need to understand the basic introduction, a very basic idea for hydrogen bond. That is good enough for now. Yeah, all right. So show you the last example. Okay, I show you the last example before we go on and finishing with the hydrogen bond. So the last example that we need to learn is, let's say, ammonia. Yeah. So ammonia, the formula is NH3. Yeah, ammonia, the formula is NH3. So ammonia is capable to do hydrogen bond because ammonia itself got H, ammonia itself got FON. So it fulfill the requirement to form hydrogen bond. Okay, so now I'll show you, I'll demonstrate how the hydrogen bond could be formed in between those, ammonia. Yeah, all right. So now we have this. So now we have the nitrogen. Okay, so you have 3H here. You can go with either one. Huh? So let's say one of the H of this molecule attached with FON of another molecule. Okay, so when the H of one molecule attached to N of another molecule, that is the formation of your hydrogen bond. Yeah, so this is our hydrogen bond. And guys, I want to give you the last example, a special case. I don't want you to think that the hydrogen bonds must form between the same fella, like for example between water and water. Okay, and then here between hydrogen fluoride and hydrogen fluoride, and here between ammonia and ammonia. It must be the same fella. Not necessary. Yeah, not necessary. They can be different molecule. As long as all molecule can form hydrogen bond will do. Example is here. Let's say we have hydrogen fluoride. We have water. They can form hydrogen bond because why? Hydrogen fluoride is qualified to do hydrogen bond because hydrogen fluoride got H, FON. So okay lah. Water also qualified to form hydrogen bond because water got H and FON. So now we already know these two fella, they are capable to do hydrogen bonding. Then how they can form the hydrogen bonding? Okay, how they can form the hydrogen bonding in this case? Okay, so very simple. The H of one fella will attach with FON of another fella. For example, the H of the water will form the hydrogen bond with the F of the hydrogen fluoride. Okay, H of this fella form the bond with F of this fella. So here you will have hydrogen bond as well. Okay, so how does this hydrogen bond differ from the previous one? Because now the hydrogen bond we have, in this case, they form between two different molecules. One molecule is HF, one molecule is water. Okay, so what is the message that I want to highlight here? So you were able to form hydrogen bond as long as you have more than one molecule that fulfill the two requirements. Okay, as long as your molecule fulfill these two requirements, high phone, they can form hydrogen bond. Despite these two molecules might be the same or might be different. Okay, so we have water can form hydrogen bond, so water can form hydrogen bond with another water, for example. Okay, water also can form hydrogen bonding with another fella that can form hydrogen bond, such as hydrogen fluoride. Yeah, okay, so I don't want you to misunderstand that hydrogen bond must be always involve a same type of substance only. Not necessary. Yeah, not necessary. Okay, so this is what we need to know. All right, so now let's go on to do the last part of the hydrogen bond before I go and discuss some question on it. Okay, so the next part that I will touch is this. Okay, so I want you to know the effect. Okay, effect of hydrogen bond. What is the effect of hydrogen bond on the physical properties of some substance? Okay, which means that if you have hydrogen bond, what and how it will affect your properties. Okay, so in short, how the hydrogen bond can actually affect the properties, okay, the physical properties, sorry, to be particular, physical properties of a substance. Okay, so if I have a substance and I know that substance is capable to do hydrogen bond, so what would be the impact, how it would affect the hydrogen bond, so how it would affect the properties, sorry, my bad. Okay, so the first one, okay, if the substance has the hydrogen bond, it should have a high melting point and or high boiling point. Okay, so the high melting point and high boiling point, I will talk about this later. High melting and high boiling point compared to some normal covalent compound. Okay, so I'll further elaborate on this, no worry. Second one, if the substance can form hydrogen bond, the substance would be soluble in water. Okay, so let me further elaborate on these two. So let me further elaborate on these two. Okay, so the first one. Okay, okay. So high melting point, high boiling point, and normal covalent bond. Okay, let's do a very quick recap. Okay, sorry, not normal covalent bond. Sorry, my bad. Normal covalent compound. Okay, so let's do a very quick revision and a recap. Okay, so let's do a revision. Okay, so when we have a covalent compound, normally for a covalent compound, for example, carbon dioxide, okay, for example, we have methane, CH4, okay, we have hydrogen sulfide, all these don't memorize, okay, all these are covalent compound, okay, they are made by non-metal and non-metal, so when we have non-metal and non-metal joining together, so we know that they will form covalent compound already. So normally the covalent compound has a quite low melting and boiling point. Yeah, generally covalent compound has low melting and low boiling point. Okay, so we have to know the reason. What is the reason why covalent compound has low melting and low boiling point? Okay, so we learned before. So when we have a covalent compound such as carbon dioxide, so when we want to melt or boil carbon dioxide, we need to overcome the force. Okay, so the force between the covalent compound is a very weak force. This weak force, we call it weak intermolecular force. Okay, we have a very weak intermolecular force. If you don't want to call intermolecular force, you also can call it as a weak van der Waals force. Okay, weak van der Waals force. Okay, so for covalent compound, so they are attached by very weak van der Waals force. When the force is very weak, you only need little heat. You only need little heat to break them apart, to overcome the force. Okay, so you only need very little heat to overcome the force of attraction. Yeah, because the force are so weak. Yeah, so that is for normal covalent compound. But when we come to the substance that can form hydrogen bonding, example, let's say we have a water. So water actually can form hydrogen bond. Why? Because water got H, water got FON. So water is capable to do hydrogen bond. So when water can do hydrogen bond, the hydrogen bond is actually stronger. Yeah, so the hydrogen bond is stronger. So you can see the water hold their hand more tightly. Yeah, why? Because they have a stronger force. Okay, this force is stronger than van der Waals. This is hydrogen bond. So the hydrogen bond is actually stronger than the van der Waals. Okay, but is still actually weaker than the electrostatic force that we can find in ionic bond. Yeah, so hydrogen bond is strong, but not as strong as the electrostatic force that we found in ionic compound. Okay, So this hydrogen bond is stronger than van der Waals. When hydrogen bond is stronger, so you definitely need more and more heat to overcome. You need slightly more heat to overcome the force of attraction. Yeah, common sense. If the force is very strong, you need a lot of heat to break it. If the force is weak, you need very little heat to break it. Yeah, so hydrogen bond is stronger than van der Waals force. So any substance that got hydrogen bond, they should have higher melting and boiling point than the van der Waals. Okay, so I want you to know this. Okay, so as a result, the water, okay, has a higher melting or boiling point compared to the carbon dioxide. Okay, water have higher boiling point than carbon dioxide. Okay, so the reason is because, okay, water can form hydrogen bond, okay, and carbon dioxide cannot. Okay, so the hydrogen bond is actually stronger than the van der Waals. Okay, is stronger than the van der Waals force between the carbon dioxide molecule. Yeah, between carbon dioxide, okay, carbon dioxide is a covalent compound. We only have van der Waals force, and the van der Waals force is weaker than hydrogen bond. Okay, therefore you need more heat to overcome the hydrogen bond. Yeah, you need more heat to overcome hydrogen bond than our van der Waals force. In exam, you cannot write short form. You have to spell the whole thing. You have to write van der Waals. Okay, so that's a simple idea. Okay, so I want you all to know hydrogen bond is stronger than van der Waals force. So if you have hydrogen bond, your melting and boiling point will be higher than those normal covalent compound that only have weak van der Waals force. Yeah, so this is what you need to know. All right, so for now I want you to see the comparison. Okay, so when for covalent compound, so they only attach by very weak van der Waals force. Van der Waals force is weaker than hydrogen bond. So if you have hydrogen bond will beat the van der Waals force. Okay, but hydrogen bond is weaker compared to the, all right, ionic compound, because in ionic compound we have very strong electrostatic force. So the electrostatic force in ionic compound is stronger than the hydrogen bond, and hydrogen bond is stronger than the van der Waals force. So you must know the sequence. Okay, all right, so that's it. Okay, so now we already understand hydrogen bond will make the substance has higher melting and boiling point in compared to normal covalent compound. Remember, you only higher than normal covalent compound. Hydrogen bond still cannot beat ionic compound. Okay, hydrogen bond not as strong as the electrostatic force in the ionic bond, in the ionic compound. So yeah, it only can win the covalent compound. Okay, second one is soluble in water. Okay, you will learn more about solubility when you go for higher level, but for now I just want you to understand a very simple idea. Okay, so any substance, okay, so if our chemical substance can form hydrogen bond, if today our chemical substance is able to form hydrogen bond with water, okay, if the substance able to form hydrogen bond with water, then the chemical substance is soluble in water. Yeah, so the concept very simple. If you want to be soluble in water, you must be able to form bond with water. Yeah, in order to be soluble in water, you must able to form bond with water. Okay, so if we have a chemical substance, it have H and FON, it is capable to form hydrogen bond. You can form hydrogen bond not with only with yourself, you can form hydrogen bond with water as well, because water also got H, water also got FON. So if the substance can form hydrogen bond with water, it is soluble. Okay, example, okay, a simple example here. Okay, I run through 1 or 2 examples here. So the first example, okay, let's say we have ammonia, yeah. So ammonia have N bonded with H. So you have H and FON, so ammonia is capable to do hydrogen bond. So then we have water. So water have O attached to H. So water has H, water have FON, water also can form hydrogen bond. So what happened is this, okay? So let's say, okay, I change the diagram a bit. Okay, I put the hydrogen over here. So what happened is that, so let's say now the nitrogen on the ammonia will go to form hydrogen bond with the H on the water. So the N of one fella form the hydrogen bond with H of another fella. So there is hydrogen bond. So in this case, since ammonia is capable to form the hydrogen bond with the water, so in this case, ammonia is soluble in water. That's it, okay? So this is a very simple idea. As long as the substance can form hydrogen bond with water, the substance will be soluble in water. Yeah, so that's what we need to know. All right. So now we already understand what is the properties of hydrogen bond. So when there is hydrogen bond, so it will be soluble in water. When there is hydrogen bond, the melting and boiling point will be slightly higher than those substance that only has van der Waals force. Okay, but please bear in mind, hydrogen bond still cannot beat the ionic compound. Ionic compound, they have very strong electrostatic force. So the electrostatic force is stronger than the hydrogen bond. So that's why the melting and boiling point for ionic compound still higher than those substance that got hydrogen bond. Okay, so let me show you some question for you to try on. Okay, the only disadvantage for now is that, okay, so for the first batch of KSSM students, as this is a new syllabus, so you don't get a lot of exercises on this yet. Yeah, you don't have a lot of exercises because this is something totally new for you. Yeah. Okay, but anyway, we will try to discuss about on about 3 questions for hydrogen bond. Okay, because at the end of the day, in this chapter, they are still focused on ionic and covalent bond. All right, hydrogen bond, dative bond, metallic bond is just some very a basic thing, or we call it some small add-on. Okay, now let me show you some question here. All right. Okay. So now we will run through 3 questions that is related with hydrogen bond. So the first one. Okay, so the first question, which of the compounds actually can form hydrogen bond? Which compound can actually form hydrogen bond? So remember, hydrogen bond, what is the key? High phone. So high phone, we have hydrogen and we have phone. So you must make sure you fulfill the requirement. So the answer is A, because you have hydrogen and you have N. Yeah. So answer B, you have hydrogen, but there is only a P. Yeah, you don't want it. Answer C, you have hydrogen, but you have S. I don't want it, I want phone. Answer D, you have hydrogen, but you have Cl, not the phone. So the best answer is A. Okay, next one. Ethanol. So ethanol is an alcohol. It is soluble in water. Okay, because why? Okay, remember, when the substance is soluble in water, it's because the substance form bond with water. I repeat, the substance soluble in water because the substance form bond with water. What kind of bond you can form with water? Hydrogen bond. So let's look for answer. Answer A say covalent bond. No. Answer B say ionic bond. No. Answer C say hydrogen bond. Yes. Answer D say dative bond. No. Okay, so I repeat one more time. If the substance is soluble in water, which means that the substance is able to form bond with water. In order to form bond with water, we must have hydrogen bond. That's the logic. Very simple. Okay, last one. Okay, so which of the following statement explain why carbon dioxide has a lower boiling point than water? Okay, so before we go for the answer, the idea is this. What is carbon dioxide? Carbon dioxide is made of non-metal C and non-metal O, so it's a covalent compound. So for covalent compound, what we have? Covalent compound, they should have very weak van der Waals force. So we should have a weak van der Waals force. If you don't want to say van der Waals, you can say weak intermolecular force. Okay, so carbon dioxide has a weak force. We call it van der Waals or intermolecular force. Okay, water. So water, it's H2O. Okay, water, the formula here. Okay, I don't have the space to write on. Yeah, so maybe I write on top here. Okay, so water is H2O. So water got H bonded with FON. So water is capable to form hydrogen bond. And we know hydrogen bond is stronger than van der Waals force. Since hydrogen bond is stronger, you need more heat to break the hydrogen bond. Okay, so we go for the answer. That is hydrogen bond stronger than van der Waals and more heat. So answer, go one by one. Answer A. The relative molecular mass is bigger. When we're talking about the, what we call that, the boiling point, it got nothing to do with the mass. So wrong. Second one, covalent bond in carbon dioxide is stronger than water. No, there are two mistakes here. Number one, for carbon dioxide, which is a covalent compound, for covalent compound, we are not breaking covalent bond. We are breaking van der Waals force. Okay, van der Waals force is weaker. Okay, not stronger. So answer B is wrong. C, carbon dioxide is a covalent compound. Water is an ionic compound. Alright, so carbon dioxide made by carbon, non-metal, oxygen non-metal is covalent compound. Water, H2O. Water made by hydrogen, which is non-metal, oxygen also non-metal. So water also covalent compound, not ionic. Wrong. So the answer has to be donkey. Water form hydrogen bond, while the carbon dioxide doesn't. Yeah, carbon dioxide don't form hydrogen bond. Carbon dioxide only form van der Waals force, which is very, very weak. Okay, so I hope, okay, now you should able to get some rough idea what is hydrogen bond all about. Yeah, so remember, okay, you don't need to go too deep about hydrogen bond. As long as you know some basic about hydrogen bond, that is good enough already. Yeah.